Okay, so this one continuing from the number 1 and 2, and no calculator is allowed. Okay, number 3, the tire of the car has radius 9 inches, and a person rolls the tire for the at a constant rate, okay, a constant rate on a level ground, as shown in the figure. The point W is right here. On the edge of the tire touches the ground at time t equals 1/2. So the height when t equals 1/2, height is 0, right? It touches the ground. The tire complete a full rotation the next time W touches the ground at the time of 5/2 second later. It will be height is 0 because it touches the ground. The maximum height of W above the ground is 18. So like maximum right here. So that's 18 inches. Okay. Of course, the minimum is 0. As the tire rolls, the height of the W above the ground periodically increase and decrease. So that shows a sinusoidal functions. The sinusoidal function h models the height of the point W above the ground in inches as a function of time t in second. A, the graph of each dashed line for 2 full cycles is shown. 5 points F through P are labeled on the graph, and then no scale is indicated, and then no axes are presented. Determine the possible coordinate. Okay. So based on the description here, um, when 1/2 second later, it will touch the ground. So touch the ground. So you can kind of extend it here. So it was here. So when t equals 1/2, and probably, yeah, I mean that's the touch the ground, right? And if you think about the period first, period is, it come back to the same height, which is a 0. So simply just a 5/2 minus 1/2, it'll be period, right? The reason why, so think about it. Let's say here 0 and here 0. So when t equals 1/2, and here's a when t equals a 5/2 and 0 again. So it's a 1 full cycle like that, right? So that's a 1 period, which is a 4/2. So 2 second is a period, right? Okay, uh, so that divide by 4 basically, which is a 0.5 second. So why I divide by 4? So if you think about from here, 1, 2, 3, 4. So 1 period, if you split it into 4, then that will be easier to label those points, right? So each one, remember that each one you add a 0.5 or 1/2 second, like that, right? So then this F coordinate then 1/2 plus 0.5 plus 0.5, which is just add 1. So 1/2 plus 1 is then 3/2. And that time, maximum was 18, right? 18. Now, G is you add another 0.5. So let me make it this one then. I think it will be better to make it decimal. So then this one is a 1 plus 0.5 is a 1.5 here. And this one is you keep adding 0.5, so this is a 2 comma. Now the middle line should be half of the 18, which is a 9, right? And here is you keep adding 0.5 again. So 2.5 comma 0, the height is 0. And here K coordinate should be then you add the 0.5 again, which is 3 comma 9. And the last one here, then 3.5 comma 18. That's a max another one, right? Okay, those are answer. Those are coordinate of all the 5 points. Now B, function h can be written in the form of this, the sine. Okay, so I'm looking at my sine graph, like maybe you can add more here. So it's like this, right? Why? When t equals 0 then, right? So this is a 0.5 here. So what I'm gonna do is this one is 1 period, and it will be upside down sine, right? So you can say what is the amplitude first? Amplitude is a max minus minimum over 2. That's the definition of amplitude. Maximum 18. Minimum height is a 0 divided by 2 is a 9. Okay, so then what is the A value? Since I'm looking at the upside down sign graph, your A value is not positive 9, it should be negative 9, right? And then it start from 0, so you don't have any horizontal shift. So C value must be 0. What about period? Period is a 2 pi over B, which is a period we found it was a 2 second. So 2. So then 2B equals 2 pi. So B is a pi, right? So I found the A value, B value, C value. And D value is a vertical shift, which is basically right here, right? So that's the vertical shift. So that's a 9 unit up. So your D value is 9 also. Okay, so I found out A through D. That's the answer. Okay, now C. Refer to the graph of H in part A, the T coordinate of the K, point K, and T1. Okay, so where's the K? So this one, right? So this is T1, and T coordinate of the P is a T2. So this is a T2 here, right? This one, T1 and T2, like that, K and P. Okay, now, so first one, on the interval T1, T2, and which of the following is true about graph of H? Okay, let's see. So between T1 to T2, so what is the graph going here, right? So it keep on going, okay? It's a positive because above 0 is a positive and then increasing, right? So if you see answer choices, then A through D, positive increasing, so A answer, right? Now, second one, describe how the rate of change H is changing. Remember, the rate of change of H is slopes. Okay, slopes of graph of H. So if you think about it, between here to here, your slope is keep on decreasing, right? Keep on decreasing. That slope of the tangent. So you have to say rate of change will be decreasing, right? Decreasing. So you can say decreasing on T1 comma T2 because the graph of H is concave down, right? There'll be enough to explain. Okay, let's move on to the next one. So that's the last question in this free response 2024. Okay, so in the beginning, that's the directions how to look at the problems. Here, let's look at A. The function g and h are given by g of x is like that, h of x is like that. Now solve g of x is 10 for values of x in domain of g. Okay, so you substitute g in here, substitute 10 into g, so 10 equals e to the power of x plus 3, and then you take ln both sides, so ln 10, and then ln of e equals 1, so it will be just x plus 3, right? Then you subtract 3 both sides, so x equals ln 10 minus 3, or you can say negative 3 plus ln 10, same way. So this is the final answer. And then you're not supposed to use a calculator, so leave it like that. Now, second one, solve h of x is pi over 4 for values of x in the domain of h. Okay, so you set this one equals a pi over 4. Okay, you look at this way. Then that's an arc sine, so you can rewrite this one as then sine pi over 4 equals x over 2, right? So arc sine x over 2 equals pi over 4. Then if you make it sine, then sine pi over 4 equals x over 2, right? It's like example, sine like pi over 6, that's 30 degrees 1/2. Or you can say arc sine of 1/2 is a pi over 6. That's the same expression like that, right? That's how inverse function related. So what is the sine pi over 4, which is a root over 2? That is x over 2. So when you multiply 2 both sides, then x is a root 2. So that's the final answer. Okay, leave it like that. So Is it in the domain? Yes. Root 2. Yeah, that's in the domain. Okay. Now let's see. I mean, how you gonna look at it? So this one, think about it. Root over 2 is less than 1. So as long as this value is less than between 1 and negative 1, that's in the domain, right? Because sign value, it cannot over 1 or less than negative 1. So root 2 is good. Now B, the function j and k are given by like that, okay? I rewrite j of x as a single logarithm base 10, which is a common log without negative exponent in any part of the expression. And your result should be in the form of this. Okay. So your j of x will be, the addition you multiply, then subtraction, it goes on the denominator. But remember, this 9, you can move it up here as an exponent. Okay. So if you do that, log 10. So let's make a big fraction. So 8x to the 5th power times, because addition, and 2x squared. And then denominator should be x to the 9 then. Okay. So I have a one single logarithm, base 10. That's the direction here. So log base 10. And then you can say, now you can simplify a little further. So 16 x to the 7 over x to the 9. And then you can go last step, log 10 is then when you reduce, then 16 over x squared, right? So that's your final answer. Okay. And then you can say your domain is x, it should be greater than 0 because of this, right? X cannot be 0 or negative. All right, second one, k of x is single term involving tangent x. Okay, so this one, how you gonna make it? Tangent x. All right, so one of the Pythagorean identity you should remember, sine square x plus cosine square x is 1. So if you subtract sine square both sides, then cosine square x is 1 minus sine square x. So I'm going to replace this guy for cosine square x. So cosine square x over then sine x times secant x, we know that that's 1 over cosine. And one of the cosine cancel out, right? So you have cosine x over sine x. But you have to make it in terms of tangent x here, right? So this one is basically cotangent x, and the cotangent is 1 over tangent x, right? So that's final answer, 1 over tangent x. That's one single term involving tangent x. Now C, the function m is given by m of x is inverse cosine of tangent to x. For all, find all values in the domain of m, yield output value of 0. Okay, output value of 0, so you substitute 0 into m of x. And cosine inverse, arc cosine, tangent to x. Okay, so you can rewrite this one as like cosine 0 equals tangent to x, right? Okay, now what is a cosine 0? Cosine 0 is 1. So tangent to x is 1. Okay, so that means 2x. Think about it. Well, what value of angle tangent is 1, which is basically pi over 4, right? And plus like n pi. N is integer, right? You have another one, which is basically, if you think about, or student take calculus, but here, but this one is a pi difference anyway, so you don't need to find the like 5 pi over 4 because it will be included here, okay? Because n is integer. So when you divide by 2, then your final answer x is then pi over 8 plus n over 2 pi, and then write down n is an integer, right? Okay, so that's your final answer. It covers then all the angles to satisfy that condition. Okay.